In these videos, we're going to have a look at how to answer the examples in the chapter on trigonometric functions in the textbook. Question 1. Express sin theta plus cos theta in the form r sin theta plus phi. What I'd like to do before we do any calculations is to build a model in Excel. So we're going to have a sin theta plus b cos theta. We're going to calculate r and we're going to calculate phi. And I'm going to give myself a constant over here that I'm going to call d theta. And I'm going to set d theta equal to pi divided by 10. I'm going to draw a graph and then I can use d theta to change the range of the graph. So let's have a column now for theta and a column for y. I'll put the first value of theta equal to minus 2 times d theta. And then I'll put the next value of theta equal to the previous one plus d theta. Now I need to make the 2 a constant so that that will repeat itself. And now I need values for a and b, which in this case were both 1. So I'm going to say that this is equal to, it's 1 in this instance, but we will change it later. So it's going to be c3 times sine of theta plus b times cos of theta, which is c5. I need to change the values for a and b so they remain constant. So we'll press F2 and put a dollar in front of the 3 there and a dollar in front of the 3 there. So now if I copy this cell down, it will recalculate properly. And if I press F2 just to see which cells it's calling on, that's correct. That's what I want. So now I'll copy these values down to about 30, I think. One more. And now I'll mark these and insert a graph like that. Now if I set b equal to 0, we should get a sine wave, which we do. And if I set sine equal to 0, I should get a cosine wave, which I do. So we start with cos equal 1, it goes through 0 at pi and it comes back to 1 at 2 pi. And if I set b equal to 0, I should get a sine wave. So we start at 0, we reach 1 at pi over 2, we reach 0 at pi, we reach minus 1 at 3 pi over 2, and then we're back to 0 at 2 pi. So that works properly. So we'll set that back to 1. Let's just remind ourselves how to find r and phi. R is equal to the square root of a squared plus b squared, and phi is equal to the arctan of b over a. So r is equal to the square root of a times a plus d3 times d3. And phi is equal to the arctan of b divided by a. Excel has 2 arctan functions and I'm going to use one called a tan 2, which first of all asks for the x value, which is a, followed by the y value, which is b. So now what I'd like to do is I'd like to calculate another column. I'm going to call this column y1. So in this column I'd like to set this equal to r times sine of theta plus phi. And I need the 3's to be constant, so I'll put dollars in front of them. A dollar there, a dollar there, and close that bracket. And now I'm going to copy this line down And now I'm going to add the y1 column to the graph. So I'm going to say select data, add a new series. The x values will be those, and the y values will be these. Okay. Now we've got an orange graph instead of a blue graph, and the reason for that is the blue graph is underneath the orange graph. So what I'm going to do is I'm going to add a small increment to this, plus 0.05, and then I'm going to copy that down to all the other values, and that will lift the orange curve by 0.05. So now you can see that the orange curve lies exactly on top of the blue curve, except I've lifted it up by 0.05. So what this is showing us is that the first column is a sine theta plus b cos theta added together. The second column is r sine theta plus phi. So we can now change our caption and say that that is equal to r sine theta plus phi. So we've now got two values, 1.41 and 0.79. So we can now put the values in, which is 1.41 sine theta plus phi plus 0.79. And are we right? Yes, we are. Now, having built a model, we've now actually got the solutions to questions 2, 3 and 4. So question 2 is 3 sine plus 4 cos. So if I go back to the model, 3 sine plus 4 cos. So r is 5 and phi is 0.93. So if we go back to baseline, we've got 5 sine theta plus 0.93. And are we right? Yes, we are. Question 3, a is 5 and b is 12. Go back to our model. A is 5, b is 12. So r is 13 and phi is 1.18. So back to baseline, 13 sine theta plus 1.18. Close brackets. Are we right? Yes, we are. And then question 4, a is 1 and b is the square root of 3. So back to the model. A is 1 and b is the square root of 3. So that's going to give us r is 2 and phi is 1.05. So we'll put that into baseline. R is 2 times sine, 2 times sine theta plus 1.05. Close brackets, and are we right? Yes, we are.